Hi, this is Mrs. Lewicki, and we're just going to do a little medication calculation review for Adult Health 1. Each semester you have to do a medication calculation quiz. This isn't worth any points, but you do have to make 80% or higher in order to be able to administer medications in clinical. Retakes are allowed. The quiz is a combination of multiple choice questions and calculations. The multiple choice questions involve things like rules of administrations, conversions, and calculations. Conversions include mics to milligram and pounds to kilogram. Now, the majority of the questions are actual calculations, so you will be doing those as well. This is a paper and pencil exam. The types of calculations will be, I'm identifying it as standard, like how many capsules or tablets will the nurse give, how many milliliters will be given. Um, there will be weight-based calculations, and weight-based calculations are you're ordered to give so many milligrams per kilogram, and the patient weighs however much. Divided doses, and I've got examples of both of those things. Divided doses are the patient's ordered so much in the day to be given over in so many doses or every 6 hours. IV rates, that's usually mils per hour. Well, let me rephrase that. IV rates are always in mils per hour. IV drip rates, correct syringe dose, and I've got an example because I didn't know actually how to label it in the type of calculation, and also calculating time. And what that means is when is this bag going to be finished, this IV bag, that type of thing. So there are several examples, and I'm just going to run through a couple of these. I'm not going to give you correct answers here. You can find the correct answers on the if you look in the notes part of the PowerPoint that doesn't have the voiceover. You want to be able to look at what medication doses are correctly written, and in this case it says select all that apply. And you're looking for all the components. Is the medication name there? Is the dose there? Is there a trailing zero, or is there a zero before the decimal point? Is the route listed and the time? You're also going to be doing conversions. In this case, it's a mics to milligram conversion. So you would want to do that. I don't think I listed that. I might have listed that, but that's one of them, mics to kilograms. There's also conversions of grams to milligrams. Standard dosing. I really, it's not standard dosing, but the way it's phrased, but it's a standard type calculation, which is a dosing. So that in this case, the doctor ordered amoxicillin 500 milligrams every PO every 12 hours. What you have available is amoxicillin 250 milligram tablets. How many tablets will the nurse give? That's a lot of people do. Now I can't remember the calculation method. I usually do a D over H times V method. But whatever way works for you, you do that. I'm not going to give answers, but the answers, like I said, are in the notes pages of the PowerPoint. Another standard calculation, this is an elixir, so how many milliliters are you going to give? I've given a few hints here in the PowerPoint. So when you're performing medication calculations, always think about what you are administering. Can you actually measure the dose you get? So if you're looking at milliliters, this is an oral medicine, so you would pour it in a medicine cup, but can you measure part of an ml? So you want to think about those kind of things. Weight-based calculations. Now, when you get to the fourth semester, these weight-based calculations become more complicated than what you have here. This is more pediatric dosing or other weight-based. So once a day, you don't, because in the fourth semester you include how many minutes and things like that. This one is you've got a standard dose. So this is 1 milligram per kilogram, subcutaneous daily. You're going to have to convert the weight from pounds to kilograms, and then determine how many milligrams they're getting, and the available dose is here. So a couple of other hints. Rounding usually occurs at the end of the equation. Sometimes if the pounds to kilogram conversion comes out as like whatever kilograms 0.123, you'll usually just use that number, or if it's a higher number, you'll round up at the kilograms, because otherwise your math ends up with a lot of decimal points. The hint number 2 is, although it's got the slash there, that usually is a symbol for divide. When we're looking at milligram per kilogram, that's what that means. It's per kilogram. So for each kilogram of weight, the patient is going to receive 1 milligram of the medication. So that means it becomes multiplication rather than division. It's not really meant to confuse you. It's just a math thing is what it boils down to. So when you see it as is here per kilogram or per 0.4 ml, you have to think of it as per. Next thing is divided doses. So here's an example. The doctor ordered 1 gram per day in 4 divided doses, which are every 6 hours. So how many milligrams should the patient receive every 6 hours? Here's the medication. How many capsules will the patient receive? So when something is ordered in grams or liters, you want to convert that to milligrams or milliliters. It makes it an easier calculation, because if you're doing it in grams and you divide that by 4, you're going to get 1/4 of a gram, where it's easier if you then make the conversion earlier and call it 1,000 milligrams. Drops per minute. So you should have learned this in semester 2. An IV bolus of 100 milliliters is ordered to infuse in 30 minutes. So when you're calculating drops per minute, you need to know the drop factor. And the drop factor, which is what in this question it says, on a set calibrated at 20 drops per ml. The 20 drops per ml is the drop factor, and you want to calculate the flow rate in drops per minute. And that means that you're standing there with your watch counting the drops. So that go in 1 minute, and that's how you adjust your rate. And believe it or not, we used to do this, and I would like to say that we never do that anymore, but a little bit of personal information. I get an IV infusion of medications once a month, and sometimes they have trouble with the pump, and they actually have to do the drop counting. So this is 2019, and we still actually do that on rare occasions. It does still happen, but it's pretty rare. But you cannot count a partial drop. So if you come up with a number like 33.3, you can't count 1/3 of a drop. So that's where you should naturally think about rounding. Here's another of the same thing, drops per minute. It just has a different flow rate. And then calculate rate in milliliters per hour. IV rate is always milliliters per hour if you're putting it on the pump. Absolutely always, forever and ever. So this gives you the morphine, the medication that the patient's getting, 2 milligrams per hour, and it's mixed as 50 milligrams in 50 mLs, and calculate the mils per hour flow rate. Measuring in a syringe, again, I didn't know how to label it on the bullet list at the beginning. So what we're asking you to do, the doctor ordered 15 units of regular insulin. We want you to mark where is the 15 units. Should be a gift for you. You can mark it, you can color it in, however you want to do it, whatever it is, so that you know. This is a very, you just need to look at the picture and mark the correct dose. And then calculate time. And what that is okay, it's 8 a.m. and there's a liter bag of TPN that started at 100 mils per hour. And so when do you expect the infusion to be completed? Or in other words, when do you think you're going to need to hang your next bag? So what's that answer? And make sure you put it in military time. All right, and that's the end of the calculation PowerPoint.